Good afternoon. So our interest in blue carbon actually stems from our interest in studying large mega herbivores in 2 island systems in India and their effect on seagrasses. That's what actually got us interested in finally seeing how they could actually be affecting the carbon stored in these seagrass meadows. So we've been doing considerable work in these 2 island archipelagos of India. One is the Lakshadweep archipelago on the west coast and the Andaman and Nicobar archipelago. And some of our work in the Lakshadweep archipelago, mainly on green turtles, were actually showing, so in just to give you a bit of a background, so in Lakshadweep we have green turtles whose numbers are really high. We have about 6 turtles per hectare there, and the herbivory rates are also extremely high. So what we were looking at is to see what we were finding was basically these turtles were wiping down the above ground biomass, subsequently wiping down the below ground biomass, and eventually they were also reducing the amount of carbon in the first, the organic carbon in the first few centimeters of the soil. So that got us interested, and we thought, why not see what another large herbivore in the other archipelago that we were studying, namely the dugong, what could possibly be the effect of its feeding on the seagrass meadows there. So just to give you a background about the Andaman, it's different from the Lakshadweep archipelago mainly because it has 12 different species of seagrasses, so that form mixed species and monospecies meadows. And when I'm talking about the monospecies meadows, they mainly comprise of the early successional species like Halotulia and Halophila, whereas in the mixed species meadows we have Thalassia, Cymodicea, and Halis, and Syringodium. And these meadows experience a fluctuating sediment regime. So during the monsoons, we have a huge load of sediment that actually comes into these seagrass meadows. And some of these meadows, so we have about 70 to 80 seagrass meadows in Andaman, and of which almost 80% of them are comprised of these early successional species. And what we've been finding from our studies on dugongs is that the dugongs are actually mostly feeding only on these early successional meadows, early successional seagrass meadows. So that got us to asking 2 questions with respect to this study. One is, how does carbon actually vary in seagrass meadows comprised of this early successional and late successional species? And the second was that how do these external factors, namely dugong herbivory, affect the carbon stored in these meadows? Another thing what I forgot to tell you is that so in Andaman we have very small population of dugongs. We probably have less than 30 individuals left, but we've been tracking some of these animals for the last 10 years, and I've been seeing that they are continuously feeding in the same seagrass meadow, which means they are, unlike in places like Australia where we have larger populations, the dugongs actually keep moving from one meadow to the other. So here, because they are so they are just 1 or 2 animals using a single meadow, so they are constantly feeding in the same meadow over the years that we've been seeing and throughout the year. Oh, I don't know how that happened. Okay. So we selected, we divided our sites into these groups where we had sites with that showed dugong presence almost over the last 10 years that we knew of. And actually even more, because we had some of our previous data from the last 50 years to show that the animals were actually feeding in those areas. So we selected areas with early successional and late successional species, and where there was dugong present and where there were dugongs absent. And then we also compare them with sites that had no seagrass. There's something wrong with the arrangement of this, but these are some of the sites where we sampled, so right across. And we use standard sampling techniques. We use cores. We had 6 cores in each of these sites, and we use the loss of ignition method to actually, so what we are presenting here is basically the percentage of organic carbon. And we found that organic carbon actually ranged from 0.103 to 8.687% of the dry weight. When we compared the carbon across the different composition, the different kind of meadows with the different species composition, we found that the late successional species had actually much higher carbon than the early successional and the barren. So there was not much of a difference, not a very significant difference between these two, but there was a significant difference between the late successional and when compared to the barren and early successional species. Then when we looked at the effect of dugong herbivory, we found that once again the difference was not very significant. So when we look at both of these together, one is, yes, the late successional species do have a higher potential in trapping organic carbon because of how deep rooted they are, and how persistent these species are, as opposed to the early successional species that have a much shallower root system. But why we actually aren't seeing this difference is probably because there isn't any difference. There isn't a significant difference to start off with over here, and hence because we are in the Andamans, we are seeing all the dugong herbivory happening in these early successional meadows. That's why this difference is not very pronounced here. So coming back to what could this actually mean for for a system, for two different systems where one is actually being affected by where a large herbivore is actually affecting a late successional species, and where the other is affecting an early successional species. So while the work in Lakshadweep was actually showing us that this could when turtles actually preferred meadows with late successional species, they could have considerable impact on the carbon in that area, only because the carbon stored in these late successional meadows is much higher. Whereas on the other hand, where we have an animal that prefers early successional species, there might be a very low or no impact on the organic carbon there, only because to start with there is much lower. These species hold meadows hold much lower carbon than the early successional species. So yeah, there were limitations to this study. One is we have yet to analyze some of the sediment accretion cores that we collected, so we don't actually know rates of rates at which this sediment actually has been accreting there. And we also have to still we still have to analyze our samples to see the source of the carbon in these sediments, whether it's mostly terrestrial or it's from which of the marine systems. So yeah, that was quick. I'm done. Thank you so much.
Thank you very much,
time for
Elrika.
your presentation.
You've left plenty of time, and I'll be very grateful later on. Thank you. Any questions or comments for Elrika? I certainly have some, so I might kick off. You pointed out that the dugong density is very low here, maybe just one or two animals repeatedly feeding on the same meadows. If anybody gets the chance, ask Donna Kwan. Is Donna here? No, ask Donna Kwan if you can have a look at her video footage of dugongs in Abu Dhabi. She showed me last night there was about 600 dugongs feeding in one very small area in these incredible aggregations. So I was just wondering, what do you think about your conclusions in relation to places like the Gulf, the Red Sea, or Australia, where there's much higher densities?
Yeah, I think the values might vary over there for sure. I suspect we might have a decrease in carbon there because just the pressure of dugong herbivory is much higher there. Although in Andamans, we do have a herbivory, the herbivory rates of almost 5 to 40% of production there. So that's not a very low number to start off with. So at that pressure, we are seeing this kind of an effect. But it might vary if we compare it to sites with much higher population.
Well, they're pretty hungry. Yeah.
Yes.
Any other questions or comments? If I can have another one then. Am I right? You seem to conclude that in the more persistent meadows where the turtles could be grazing, you thought that there could be an impact, a potential impact there. Is that just a hypothesis, or was there some evidence for that?
We've done a study, we've yet to publish it. It's being written up, so I didn't present any of that over here. But,
and that was turtles?
Yes, that was with turtles. So eventually we will probably do a comparison of both. And
fantastic. Yeah.
Just no, actually the interesting thing with the turtles is that actually they just not eat all the plants and the biomass, etc. But they actually have the capacity also to take out all the storage that you have for hundreds of years. So because of the way they eat, they flip their they flippers, yeah. And as a result of that, they actually have the ability to resuspend all the carbon. So they are not just eliminating all the carbon which is on the plants by just ingestion, which eventually the dugongs do as well, but actually they have the ability, or they have the impact of also eliminating the carbon stocks which have been accreted for many, many years. So yeah, so that's something it's coming soon in a few months. Yeah, so it's actually nice to see the contrast between the two mega herbivores just because of the choice on their diet. Yeah. Yeah, that's true. But actually, if you have such a low carbon burial in the short-lived species, you would expect no effect as well if they disappear, because the barren has exactly the same. So, at the question, what would happen if you have 200 dugongs? Probably nothing, because it's already nothing. It will be like the sediments, no? Probably it's all coming from the sedimentation. Yeah. Well, sorry, yeah.
Okay, if there's no more questions, please join me in thanking Elrika.